Okay, in Chapter 8, Section F, Section 5, we are asked to do word problems, symbolize the word problems, and use all of our implication rules and all of our replacement rules to prove the conclusions that they give us. So here's our word problem. If you get malaria, then you can get very sick and you can die. Therefore, if you get malaria, then you can die. So that second statement is the target that we're trying to prove from the original premise. So when we formalize it, when we symbolize it, we get this. Our first premise is if M, then S and D, and we're supposed to prove if M, then D. Now remember, we're working backwards from the conclusion. When we do proofs, you work backwards from the conclusion to the original premise. And if you get stuck, actually, sometimes you can work, okay, what can I do with this premise, and try to connect the dots. But basically, you're trying to work backwards. So let's think about this conditional statement, if M, then D. Which of our implication rules or which of our replacement rules can give us a conditional statement like this? There's basically three options, all right? So you could get it from a hypothetical syllogism, for example, like this. If M, then S, if S, then D, therefore if M, then D. Now, is that going to be my best way to go here? I don't think so, because I don't see any easy way to derive if M, then S, and if S, then D from this. At least it's not going to be any easier than deriving M and D itself. So I'm not going to use that. There's another one that I see that I might be able to use, and that is transposition. So in order to get if M, then D from transposition, the premise I'm going to need is if not D, then not M. Again, this doesn't look like the most promising way to go. Like, it's not going to be easy to get this premise. So the third rule that I can use to get if M, then D is implication. And in fact, this is the one I'm going to want to use. So in order to get M and D, if M, then D from implication, the premise I'm going to need to use is going to be this. Either not M or D. Now I'm trying to think about, okay, well, how do I get not M or D? And that is a really good question. And actually, I'm not sure. When I first started staring at this proof, I wasn't sure. So now I'm going to start thinking backwards from my premise, thinking forwards. What can I do? What rules can I apply to this premise? And the first one that I see is implication. Now, my implication rule, if I apply implication to premise 1, then I will get this, which I'm about to show you. If not M, I'm sorry, not M or S and D. Okay, now one reason I liked this looked promising was because it gets me to something that's looking pretty close to, it's getting me to a disjunction, which looks close to where I'm trying to get to, which is not M or D. Now I think to myself, okay, how can I get from here to here? And one rule that I see that I can apply here is distribution. So if I apply the distribution rule here, I should add in here, I'm applying this to 1, applying this to 2. Now, here's a cool thing that I see. I'm trying to get to this. Well, I see it already embedded here. It's one of the conjuncts in my in this conjunction statement here. So that means I can apply my simplification rule, and I'm already right there at the place I want it to be. So if you simplify, if both of these conjuncts are true, then each one of them individually is true. So boom, I can break that out here, and now I can apply, now I've connected all the dots here and I've got my target. So here's my point. You really want to be working backwards from your target, but if you get stuck, you can try working forward and see what can I pull out of this premise.